Good afternoon. Welcome to lecture 44 on thermodynamics of materials. So last class summary. Last class. What is this? I tell you, I consider this G2 set functions. G is H minus Ts and A is the Helmholtz free energy, U minus Ts. This is Gibbs free energy, Gibbs free energy. This is Helmholtz free energy. Both G and A state functions. Both G and A are state functions. Now what we got? Okay. First we found this dgpt. We found this is a summary. dgpt less than equal to minus dw prime. Actually, write this. When the system involves non-mechanical work, involves non-mechanical work, involves non-mechanical work, space problem, involves non-mechanical work dw prime. This I am giving you, and when in absence of non-mechanical work, in absence of non-mechanical. These two. What I got? The light has something. dgpt one by one. Follow this. dgpt less than equals to minus dw prime. I'll be series of. I'm giving table like this. dgpt, then dAVT minus dw prime. These two I proved in the class yesterday. Yeah, you have to prove yourself. dHSP less than minus dw prime and dUSV less than minus dw prime. Prove yourself. This is proved in the class yesterday. And in absence of non-mechanical work, you can write what is this? dgpt, obviously you can guess, is 0, is 0. dAVT less than equal to 0. dHSP less than equal to 0. dUSV less than equal to 0. These four sets we got. This actually, this automatic comes from this. So we write here, note here, note. Note. What is it? Less than sign reflects. Less than sign reflects. Tell me spontaneity. Spontaneous process. Spontaneity or stroke irreversibility. Irreversibility. Oh, you have a class there, down there? Class. Chemical. Equal sign, refers to spontaneity is what? Equilibrium or reversibility. And which is not mentioned greater than is impossibility. Okay, this I gave. Then also I consider this, maybe here, this space, use this space. What I said, for a fixed mass and fixed composition system, you know, okay, this can call system, okay, system, as the e.g. for example, 1 mole ideal gas easiest, 1 mole, e.g. 1 mole ideal gas, coming, or 3 moles iron, so 1 mole ideal gas, okay, etc., etc. Don't worry. What is the what relation you got? dg is VdP minus SdT. dg is VdP minus dI is minus PdV minus SdT. dH is TdS plus VdP. Then another is du is TdS minus PdV. Okay, these four. One I proved yesterday. This one, these two, these three. I'll show soon, very fast. Okay, or say okay, that's right. Very good. This, remember here, note this. Call this table 1. Call this table 1. Save this for the whole class. Save this whole class. Table 2. Table 2. This is table 3. Okay. Table 3. I will do this. This is table 3. Okay. Right here. Okay. Table 3. Table 3. No problem. These 3 tables I have given you. What is this? What it gives you? What indicates? This is tell you. This indicates G is a function of pressure, temperature. A is a function of, I can write this, function of volume, temperature. H is function of S, P, and U is function of S, V. We say natural choice for G. Natural choice. If you ask natural choice of variable, okay, variable, this is natural choice of variable. What is it for G? For G is what? Variables. If I ask for G is a function, remember, a state function. Is function of how many? Fixed mass, fixed composition. So this part. How many variables? Second class, first class. How many? State is a function of how many variables? For a fixed mass, fixed composition system, given mass and pure substance, the system, how many? 2 only. Go back. 2 only. Not 3 or 4. 2. So 2, you see every time 2. But naturally, these are coming naturally. But yet, when it is these are independent. Remember, these are independent. Natural choice of independent variable. Write this. I have to write this. Independent variables. Write this. Natural choice of this is the list. So you do this. What is the natural choice for this? Naturally coming. So what is the independent variable is what? How many is what? How many? State is given by how many variables? 2, I guess. 2 means any 2. The moment you say 2, any 2. Freely, independent means independently. So remember, any I said, I did a practice session that time. If you can follow this, what I can do. So 2, so you have to, okay. Very quick actually, 2 variables. State. This is state property. State is or any state property is. This is which is dependent, which is independent here. The equation, which is dependent, which is independent. Hello, Nirja, which is dependent, which is independent here? And G is dependent. Left hand side is dependent. Independent. 2 gives speed of phase rule also 2. I explained why 2. Others are automatically fixed. PV, T will be automatically, PV n fixed. So 2. Now what I say, but 2 is any 2. Add also, any freedom is what is freedom? Any, sir. But I am saying today that naturally pressure temperature. But any 2 means I can consider pressure volume. I'm free to consider Vt, but naturally it comes and you have some advantage through this equation. We'll discuss this. So natural choice for Gibbs for G is Pt. 2. What is this for? Tell me. Vt. What is the Helmholtz free energy? Vt. What is this? Tell me enthalpy. Sp. And what is internal energy? S. Natural term. And what is this? I tell you, I'll explain it. Why naturally coming? Acha. Let me explain. This was done last class. This was shown. Acha. Chemistry valid for what I said. Valid for a process. One mole ideal gas is taking a process where pressure is changing, temperature is changing. What is the free energy change? The free energy change. This equation I integrate. So this is the equation which is showing if pressure and temperature changes, what is the change in free energy. So what is the process? Valid for equal value for reversible and irreversible process. Equal. Because state property. Since G is a state property, since these are state property, left hand side. Very good. Very good, very good, very good. Okay, state property. For example, I tell you, suppose what is the application of this? These were discussed last class. Discussed last class. Shown last class. Proved. Shown in the last class. Shown last class. Shown in the last class. So today I will show you. This is shown in the last class. These 3 remains. I will show it first. But remember this. Okay. Do think these are state functions. What is the application? Okay, you think about the application. You are actually lagging behind. You follow rather than actually talking with him. You follow. You are absent last class. I am watching actually. Who are present, who are absent. It is better you follow this. See, these are useful, very useful. The whole remaining thermodynamics based on this. Remaining means you say whole life. Is this discussion? This. And see here, don't have to look down. See here, this is whole life. This much. So valid for reversible and irreversible, this I say, but it is a fixed mass fixed composition. So several questions are coming. Okay, I'll discuss. I'll show these 3 soon. Presently, I'll show. But before this, I'm asking you something. The first of all, tell me what is the application of this equation. I'll show this. Okay. Let's quickly. First, I'm showing this quickly. Let me do one by one. So dA. A is start. To prove, to show dA is quickly minus PdV minus S. I could not do this last day because we don't have time. A is what? Start. A is what? I said A is quickly. U minus Ts. Quickly. See, G is H minus Ts. A is U minus Ts. Don't have time to, okay, see. Waste time. dA is what? Or dA is what? du minus Tds minus sdt. You consider reversible and that result will apply to irreversible also. If it is reversible, what is this? If reversible, apply reversible. What is this? Tell me. Tds is what? dq. Oh, you look at this as if you don't know who are they. dq reversible is Tds. ds is dq reversible by t. So now you don't have so much time. du minus dq is what? See, prepare here itself. Don't have to go back home and prepare. Here. Everything is over. This whole piece will be over here. In half an hour, everything will be over. Don't have to look back. du minus dq is what? Minus first law. Minus dw. minus SDT, DW, what type of DW? What I have considered? Reversible. So minus PdV, and you all set. See how easy. You all set. All set. So similarly, start. Next one, quickly. I'll remove this soon. I'll remove this. H. How will you start? How shall I start? How shall H? How shall I start? H is U plus PV. H is U plus PV. Okay, DH is du plus PdB plus VdP. What is this? Reversible, apply reversible. Again. So what is du? PdB is what? dW, again back, dW plus VdP. What is du plus dW is known as? dq, first law, dq plus VdP. What is dq under reversible condition is known as? TdS. So these talks are not giving satisfaction. VdP, dq is what? TdS, under reversible. So this one, out. So how long it takes? I will be happy, say you try yourself. You try yourself now, okay? Now, so similarly, next one, last one, start. How do you start, Ricky? Let us see how can we apply. Du is, huh? That is not. Better. First law itself, one line. It is not even two lines, first law. dq minus dw. You should be smart in first law. Then second law, okay, depart. Mastery of the equations. Reversible, apply reversible. What it will be? Tell me. TdS minus PdB, and that's it. I've written that. So how long it takes? So next, see, naturally coming. So that's what I'm saying. Naturally coming PdB, VT. Naturally coming enthalpy, SP, and internal energy naturally coming SV. But this is the okay derivations. Okay, I will remove this. Okay. So next questions. We will answer these questions. Okay. What is the application? What is the application of this? So apply. DG is VdP minus SDT. A problem. How will apply? Where you will apply? Practical application. Sir, isothermal process. Suppose I consider an application. Consider an isothermal process. Isothermal process with n moles ideal gas. N moles ideal gas, quickly. For you, tell me what it is. DG is what? Apply this. What is the DG? DG then delta G? No, fine. Consider as and find delta G. Find delta G for the process. Apply. Delta G means DG first, then integration. DG is what? Tell me. VdP, good. Under constant temperature? VdP, these applications I am showing. V is what? VdP is what? V is what? nRT by P, dP, integration. 1, 2. What is the delta G? The one you have to find. Delta G is what? Means G2 minus G1. That is, as you know, G2 minus is what it is. nRT, T will be outside. T will be outside. Amartya, T will be outside. Why? Constant isothermal process. That's why it has dropped. That's why it will come out. nRT ln. What are you? P2 by? That's it. This is the application. If I say it is 10 nanosphere, it is 1 nanosphere. Can do? 10, 1. Temperature is say 500 Kelvin. N is 3. Can do? This problem. So don't think at the equation. See application. What is the penalty? So remember this you can get. Okay. So this is the application. Okay. Come on in. Okay. So this is the application. So next question. Next question quickly. So consider this. Next question. Consider this relation. That is what? See, I have noted this one thing interesting. See, dG PT. What is this? PT. dA VT. this I proved. These two I proved. This I asked you to prove in the assignment problem. Okay, and this assignment, and this is also likewise the same one. Also, I said what is the starting relation? Like ds system minus this I say. Okay, see matching SP, DHSP, HSP, and DU SV. So it makes sense. Everything is actually in a system. So consider the relation. Now this is interesting. DH is TTS plus BTP. So what is the what is the natural choice? What is the natural choice? Tell me. H is a function. H is a function of. Tell me. I tell you. Participate. Don't look at. Okay. Don't be distracted. See here. Participate. If you participate, then I can go past. If you don't participate, you cannot. Then I will actually. I have to repeat, and only this much progress, because you cannot participate first. So what is this? What does it mean? H is a function of what? This I have repeated this. I have taken up this one. This one here. Repeated. Repeating is also difficult. No, sir. You are written here. You are written there. Sir, perhaps very difficult. Sir, no, sir. You write here, sir. This equation must be. Is it that? So follow. I am written. I am explaining something very useful. I am removing your mental block. After you memorize, try to memorize, and you will be mad, crazy, totally insane, and go to asylum. I mean, I think you have to go to asylum unless you master. See, many more relations are coming first. See, there are many. So follow. I will tell something. Let's consider the relation. In the light of this relation, I am removing your mental block. What I said here, as if what you say, H is a function of. I wrote here. SP. You see here SP. Function of SP. So sir, as I say, I can. What is this SP? Naturally coming. Okay, naturally coming, you consider. This you may consider. But I said what? Naturally coming, but we are free to do. Any two. What are the any two? Any two. For example, also, we can write, also, at the same time we can write, at the same time, we can write, this is a natural choice. Natural choice. I am writing H is a function of PT. How about this? Any two. See, any two, then that makes our mind free. Have you used ever? PT is possible. Can I write H is a function of PT? PT. So what is the rule? 2 degrees of freedom. And any two. 2 is any two. No, this is 2. And mutually independent. Of course, independent. These are independent. That is sure. Independent side, right hand side. Right hand side independent. Left hand side dependent. PT. H is a function of PT. Have we used ever? Can I write? Are we entitled to write this? Or have we ever written anyone? Hey, 70%, 21. Tell me, have you written ever? Where? Thermodynamics. Already, sir, already. We didn't know entropy. Before that, we used this. Thermodynamics delta H is reactant product. Started with this. Delta H is actually finally H product minus H reactant for any reaction. Starting point is this. And also what? N1, N2, N3, N3. So PT. That means yes, we can. Very much we can do. We have already done it. Now, what is the difference between these two, sir? So it's fine, sir. Can I write? Can I remove your mental blocks? All blocks. There are many thousand blocks. Can I write H is a function? Either true or false. True or false. What will you do? True or false? Sir, false. True. Last moment, everyone saying true. True. Most people saying true. False. Most people were saying. And now you are saying. Questions. Who will answer? Can I write PV? Tell me. Answer. Can I write this H is a function of PV? Yeah, ideal gaseous system. Iron is the system theme also. Iron. Given size. PV can I write any given size of any ideal gas? I have said. Iron can be. I can write this already shown. Yeah. I can write this. How will I write this? Okay, this you have already used. You can write this. So why cannot, sir? Why cannot you don't understand? Any two, sir. Any, do you know what is the meaning of any? You know what is the meaning of any? Any independent two, you know what is the meaning of any? Let us say, I will write. So Google search, what is the meaning of any? So any, sir, any independent. Yes, play with that. So remove mental block. If it is not removed, then you will I will not write. Always afraid, always fearful. No. Always actually, doubtful, uncertain, tentative. Perhaps I've done well in that examination. But people don't know myself. What is good or right, what is wrong. Yes, sir. Yes, sir. Anything, I'll dance upon it. Now, see, this is this. This actually, how will proceed here? I'll proceed here, dH is, how proceed? Del H by del P at constant temperature dP, remember? Plus del H by del T at constant pressure dt. This is your famous, okay, this, here how will you proceed? How will you proceed here? Tell me. Similarly, dH is del H by del S at constant pressure ds plus I have no space. You can say any, then importance. But this is naturally coming. This I use where pressure temperature was very important, sir. We carried out the chemical reactor, constant pressure, cylinder piston, constant pressure, thermostatic pressure temperature. Or continuous reactor, furnace, controller, temperature, open to atmosphere pressure. We use this practical. This is natural. Naturally, we found the moment we derived all this. A great difference. The difference is this. This is very useful. We have already used and we will keep using. And why it is used, I tell you. I will use. But this has some quality or some importance. Okay. Or I would say actually it is some some application. What is this? Follow DHSP DH under constant pressure SP and DHPT. What is the difference? Sir, this can be done. DHPT I did. When you write more terms, N1 N2 DHPT I do. Here also N1 N2 plus. Sir, DHSP DHPT. The difference is that DHSP is the criterion, universal criterion of spontaneity and equilibrium. What else you want? But DHPT does not make a criterion. This is very important line. DHPT will never make criterion. In terms of pressure temperature, who will make criterion? In terms of pressure temperature constant, which will make criterion of spontaneity equilibrium? DG, sir, pressure temperature will be a criterion, sir. We didn't use this as a criterion. When you use we didn't use at all criterion. In fact, we didn't talk of criterion. Criterion is after the second law. These are all statements of the second law, right here. These are all the statements of, alternative statements of second law, right? Somewhere here. Alternative statements coming from DS universe. So all are alternatives. All these two table. Table 1, table 2, alternative statements of alternative, right here, statements of the second law. What is the original? Last day I said, okay, many of you absent. DS universe is greater than equal to, as we started. So we proved actually this yesterday, and these two we proved yesterday, and these two remains. This is assignment problem. That is universal. So this is. So you see, yes, sir, the HPT is very good, very useful, but not to be used for criterion, sir. But to be enthalpy to be used as criterion, it must be constant entropy, constant pressure, which is very difficult. Now note one thing. So of these choices, pressure temperature is right, convenient choice, common choice. That you write, then you will have difficulties over. Note here, I don't have space. I'm writing. Note this is the natural choice. Note the common or convenient choice. Common or convenient independent variable. Note the choice of the choice as common or convenient independent variables, choice as common or convenient independent variables who are is variables. These are the choice as common or convenient, common choices as independent variables. Okay, as independent variables are what? Common, practical, useful, easy, constant. You make this constant, PT, constant pressure, constant temperature. You have to do carry out a reaction under constant negative, less than 0 is negative spontaneous. Criterion, when a reaction will occur, when this is satisfied, and constant pressure, constant temperature. This is also okay. Constant volume, constant temperature. This is constant entropy, constant pressure. This is constant entropy, constant. Is it easy to control entropy? I have a temperature, constant temperature setting is there. Fixed it, knob, pressure knob, or say you have actually gauge, pressure gauge. So these are very common, amenable to variations. I can easily fix this, but these are not fixed. Volume also, but volume is so solid, there are difficulty. So what is the most common is what? The choice of common is P combination, pressure temperature. So you see, pressure temperature we will use for practical purpose. This is impractical. Entropy fix, who will fix entropy? Entropy, can you fix the entropy at this value? Entropy is good as dependent variable. It is itself dependent, but temperature is independent. Fix the temperature 1000 Kelvin. No, little more, 1200. Easy. Pressure 1 atmosphere, or vacuum, or compressed. So pressure temperature is common though. But remember, this is for criterion. These are the conditions, corresponding conditions. Good. This is one thing that I wanted to. Next question. Let us finish this. So I have shown many things here. So very important. So right. Note. The last point I am writing you. This is important. Note. DH pressure temperature may be used for enthalpy. May be used for processes, and we will often use. We already use for processes, but this will not make a criterion. Make a criterion of spontaneity, equilibrium. We will not make a criterion. That is, but what will make? On the other hand, in contrast, DHSP will make a criterion. This is less than 0. Will make the criterion of spontaneity or equilibrium. Happy? This I actually wrote you. This is important. Next question. Follow. Answer. Question. Answer. Okay. Question. Answer. That's an interesting thing. Follow this. Follow one by one. This is the origin. First write. Second law. Universe. Write somewhere. DS universe. These are coming from alternative statement. Original statement. This is alternative statement. Original statement. Right. Original second law. Original second law or universal second law statement. What is that? You know very well. What is that? Tell me. Yesterday started DS universe, which you should not. You may forget your name, no problem. This wall will at all not move. But if you forget this, people will be disturbed a little bit. DS universe. Oh, these chalks are also standing in the way. Get up then. Inequality means spontaneity. Irreversible. And equal means reversible equilibrium. And the remaining one means less than, impossible. Here greater than becomes here less than. Follow the deduction. Follow the entropy will increase, spontaneous process, but free energy will decrease. This free energy, PT, or Helmholtz free energy, volume temperature. These free energy, these are all academic. I tell you, to your satisfaction, also to your relief. These are only things whole life. Even entropy recedes. This whole life gives energy, gives energy, gives energy. And these are also academic you may consider, okay? And this, but this is derived from this yesterday's class. And yesterday's class again, this also. Today I'm not taking up because this is assignment problem. So another question, critical question. This is also assignment question I am covering here. Okay? See, this was it is less than minus dw prime, is okay? Minus d, follow the question, don't avoid answering. DJ, I'm watching actually who is actually looking away from me. Then I'll ask him. Because dgpt less than minus dw prime 1 or irreversible. Irreversible. Is minus dw prime reversible? Follow. System doing non-mechanical works, possible, no problem, electrochemical. So one case it is less than, another case equal to. So here it is a state property, sir. How it is one time is less than, another time is equal to. It changes. A state property. Repeat the question. State property, a chemical reaction under dgpt condition. It can be delta G also, but I am writing dg means delta G integration. Repeat. So this is a pressure temperature chemical reaction. Is dg is a zinc plus copper sulfate goes to zinc sulfate plus copper. This gives actually electrochemical cell. This is galvanic cell actually. So dgpt equals to minus dw prime if it is reversibly carried out. Oh, very good, sir. Very good. And then if you carry out irreversibly, it will become less than. By the same thing here, minus dw prime. How? But here these are state properties. I discussed this state properties. This I showed here. This I discussed. H is a state property, T is a state property, S is the formulation of G last year, how it was developed. So tell me, why? Can you see? It is actually maybe a psychological problem. Or say, what other problem? I would say mental problem. Answer this now. Given this clue, dgpt is one time reversible is minus dw prime. Irreversible less than minus dw prime. What is this? Say I'm giving you. This is I'm giving you the minus dw prime say 20. Say 20. In one time dgpt is 20, another time less than 20. Such thing. But here is a state property. Violation, heavy violation. So all thermodynamics is a gun. If this moment gone, no one will study. Okay? From hence, no one study because all are gone. Because it was violated. Other day I also told DS universe adiabatic expansion, I said violated. So gone. Second law screwed up. So no one will ever touch this subject. Here also. So state property. But there is an answer perhaps. Just have to look deeply, look at this. You know how to look? You don't know how to look. You can look actually, you are expert in actually, this mobile, smartphone, you look very heavy. You look heavily. No. I repeat, one case this is equal to less than. No, you'll say, sir, you are actually talking to your convenience. This is not at all changing, sir. Right hand side is changing. And that is expected. This is a work. Work changes from reversible to irreversible property. This is a state property. What will change, sir? It depends, sir. It is minus 20. This side is, one time is minus 20. Next time will be minus 10. Minus 30. Minus 20, minus like this. Okay, so this is never changing. So I am giving an example. Since I started, in one case, minus 20 left hand side. dgpt. Right? dgpt. Sorry, it takes time. Anything else takes time. Joule is minus 20. What is this? Tell me. Is dw prime minus dw prime is 20. Joule, non-mechanical work, galvanic cell. So very good, sir. Reversible mode. Reversible. Irreversible, reversible work is greater than irreversible there also. So if it is 20 joule, this 20 joule work reversibly, delta G is NFE, etc., it is less than 20. Anything less, sir. It will be what? If it is 20, then it will be minus 20 means 19. 18, 17, less than. So the minus d will be minus 19. Is it same? What it is? Minus 20 is minus 20 is less than minus 19. You know, negative, negative. Minus 20, minus 19 is greater. So in one case, minus 20 joule. This who is changing? Sir, left hand side has not changed, sir. Hallucination, sir. We actually have to think, oh, left hand side is not equal to. Well, psychologically, you consider right hand side is unchanged. Right side contains a path function. Non-mechanical work also is a path function. Reversible to irreversible. In one case, it provides how much work? 20 joule. And when you carry out irreversibly, anything less than that, 19. This is 19, okay? And if you apply sign, minus 19, so makes sense. So this is the fallacy. Fallacy is just a fallacy. This also assignment problem I address here. Given this, but this is such a difficult thing, na? Can you remove this? Otherwise, this comes in. Reversible EMF, irreversible EMF. Actually, I told you, gave you examples of reversible other than pressure volume type. What example I gave? Reversible process, irreversible process, evaporation of water. Then actually I thought time didn't permit, that is electrochemical cell, reversible, irreversible. Also I am telling you, okay, since I forgot that time, I told you what principle I told you about second law, like Cauchy's, etc. Any spontaneous process, how to carry out reversibly? What to? You have to reverse it. You have to reverse spontaneous process. A chemical reaction occurring zinc plus copper sulfide goes to, let me write down, I don't want to, zinc plus copper sulfide spontaneous, quickly follow. See, eternal zinc sulfide plus copper. This is spontaneous. This is spontaneous, and you are getting cell, galvanic cell. Galvanic cell used in spontaneous. Galvanic cell. And reversibly, irreversibly, don't do. Follow how to get spontaneous process. I am asking you to reverse this. Are you spontaneous? This direction I have to reverse. Reversal of a spontaneous process is not possible in an isolated system. Isolated. Suppose you take it in an isolated system, and this means this is occurring in this direction. This means this is occurring in this direction. Okay, this direction. That is, this means that spontaneous. Very good. Spontaneous direction. Spontaneous direction. Don't have to give this. Equals means this. This is isolated. Isolated system. Isolated system. No, you reverse this. No. First thing you say no. Then yes. It is not possible. Unless you break the isolation, may bring in surroundings to interact. That is your galvanic cell. Being electrode and an external source is potentiometer. Apply this, then it will give you some, okay, it is possible. So what you do this, you apply a reversible EMF, okay, more than this, then it will be carried out. So you can see, what is this? To carry out reversibly. Spontaneous process, carry out reversible, then reverse. I didn't detail this, okay, but this is another example. What example I gave you? What example in the class? Heat flow from high temperature to low temperature spontaneous. Yes, in an isolated system, it cannot be reversed. To break the isolation, low temperature to high temperature, how? Now carry out reversibly. First is carry out reversibly. That requires surrounding involvement. Carnot cycle. Then reverse. Consider reversible Carnot cycle and then reverse. That becomes a refrigerator cycle. Then you consider irreversible mode, that is just one step make irreversible all step. That's no problem. Same. So remove this. This discussion is not. It is not actually today's discussion. Okay, this is over. So what yeah. So 40. So sir, why this is this? This is equal state property. Blame state property. What is this? Wrong. No sir, this is correct. This is fixed. These gentlemen is switching. One. Now next, let us take up this one. Corresponding. This one, he said less than 0 equal to 0. What is this? Again, spontaneity. So when the reaction occurs spontaneously, say any reaction for them less than 0. and occurs at equilibrium is 0. So how shall I explain now this? One time less than 0 is negative, and that time is 0. So how will you explain this, sir? What is the expression? Last time you had a excuse argument this side. This actually changed, but 0 cannot. 0 you cannot say, sir, this 0 and that 0. Can you say, no, sir, this is 0, sir, this is reversible 0, that is irreversible 0? You should not say this. So what it will be? Another condition. I am giving a sketch for this whole life confusion removed. I am removing all this. This all removed. All. Removed. All removed quickly. Mental block. See, follow this. I am telling you. Just follow this. A plus the reaction under study. Just to explain. I have already covered 2 problems. Assignment number 5 already. 2 already addressed. Okay. To explain DGPT. It is more difficult. It is more difficult. This a little bit intelligence and alertness. Alertness. Mark the word alert. Are you alert? Do you know when to state property is unchanged from reversible to irreversible, being a state property independent of path? So condition between the same initial. Have you satisfied this? Let us see. Reaction under study. Under study, simply speaking, A plus 2B goes to 3C. Happy? When I raise equal means goes to. Okay. Under constant pressure temperature, I am carrying out in this one. So what is this? Free energy, GPT. I tell you what, is actually G prime I write actually, since N moles. A plus 2B this side, 3C that side, other day I was talking, NC, follow this. This is the picture that I don't have time. This will take actually when I discuss more into the free energy, but I can show it for explanation. This is our minima. Is the minimum. And we say equilibrium. Refers to equilibrium state. Free energy attains minima at this. This is the equilibrium. Sorry, this is the equilibrium. What is this? NC? NC is actually say 0. Say NC is actually NC increasing from 0 to 3. Add this value of NC. Maybe what? Say 1, 2. You can determine. All are present. A, B, C all present. NC has become say 1. So you know what is the value. This is 1, 2. This will reduce NC at the expense of A, B, C. This is the equilibrium state. And what is this state? At this state, what happens? The reaction starts here, then moves down, stops. So what is this point? Reaction? Spontaneous condition. This is right equilibrium state or equilibrium condition. Now follow. So you see, encircle. This is one, this is another. Follow. Equilibrium, starting from this, it says is 0, less than 0. Is 0 where? DG, delta, is starting, end, delta. And this is what? Spontaneous. This, delta. Okay, this to this, and this to this. Am I considering the same initial, same final? So that is not satisfied. So we do have no compulsion to satisfy this. So it can be 0, sir. And in fact, it is 0 in one case. It is less than 0. This is DGPT right here. Right here, verily DGPT is 0. Right here, DGPT is. Tell me, spontaneous. So happy. So all explained. Thermodynamics still stands. Actually, is. Happy. Okay. So everything I have mental blocks. I needed time. Unless mental blocks are removed, you will not be intent to study at all. This go by equations. These equations, just you throw them away. Dismiss all these things. Okay. Over. May I proceed? Have a time? Some time? 10 minutes? 15 minutes? 5 minutes? Minus 2 minutes. I have exceeded. 10 minutes I have asked. So can I remove this? I will retain these tables quickly. Let us see now how fast I can move. Shall I remove this? Quickly and very quickly. Very quickly. Start. Acha, quickly I said. So these are proved quickly. Acha, quickly. Follow this. Follow this and answer. Alternative definition of small, very small. But I am covering for a second. Alternative definitions of 1 minute of the entropy, pressure, temperature. So let us see. What is the alternative volume? What is the definition of volume? What is the definition of volume? Do you know? What is the definition of volume? Yes, you actually, your name is, I forget, Sukanto. Volume is what? What is the definition of volume? Yes? No, that is. Now, the space it occupies. That is occupies, or mathematical length, breadth, height. But today, thermodynamic. See, thermodynamics says what very interesting. It says, these what? Take a look from this quickly. BDP. See, I'm writing. Follow. Del G, del P at constant temperature. Are you happy? I hope you are happy. Constant temperature means out. Del G, del P. So rate of change of free energy with pressure under constant temperature is the volume. Rate of change of gives free energy with pressure under constant is volume. Alternatively, tell me quickly. See here, what is the B? Here, tell me what is this? Yes. Del H by del P under constant entropy. So right there. This is so easy. Then what? Take next one. Minus S. Minus S is what? Or S is what? S is what? Tell me. S is here. Del G by del T. Tell me. Del G by del T under constant pressure with negative sign. Take a look here from the first one. Minus S. Okay. And what is the minus S again? Yeah. So del A by del T under constant volume is del A by del T under constant volume over. Okay. Minus sign, na? Minus sign. Okay. Then what is pressure? Okay, pressure. What is pressure? Here, pressure. Pressure is what? Del A by del V under constant temperature. Okay, and minus del A by del V under constant temperature and negative is what? Another pressure right here, down here. Del A by del V. Del A by del V. Del U. Thank you very much. Del U by del V under constant. Is okay. Then last is what? As I said, T. What is temperature? Temperature is the thermal condition which decides heat will flow in which direction. Physics. But today, what is temperature? Del H by del S at constant pressure. What else? Del U by this chart, this table. Okay, this is another table. I will remove this table. Okay, over. Okay, remember these two are useful. Note this. These two frequently used. I am giving you. Others are of academic, or mostly of academic interest. I tell you here, similar come. These are conditions. Non-mechanical, no non-mechanical was physics possible, or this also you may consider. These are 1, 2, 3, 4 conditions. This will be used. These are academic interest. These are of academic interest. Okay. So these are okay. This is another thing that next quickly. Just check. Maxwell relations. He'll come. Oh, he will be upstairs. He will be upstairs. No? 10 minutes I have already given him. Ask him. Okay. Remove this. Remove. Okay. Next is Maxwell. Quickly. Let us see quickly, and it will not take much time. Maxwell relation. There are also assignment also there. Okay. See. Maxwell relations. Okay. See, start. Say Z is a function of xy. dz is what? Del z by del x Quickly. Y dx plus del z. I am going very fast. You just keep pace only. Very fast. I can go. Call it m. Okay. Call it m. Call it n. So what it is? M dx plus n dy. Happy? Then I am writing now del m by del. Follow what I am doing. Follow del m. See del m by del y. Back constant x. Magic. Del m by del y constant x is what here? Del n del x constant back y. What there? Quickly. This is what? Okay. See. No. Is what? Oh, sorry. Is what? It is what? Del y. What is m? M is what? Del z, del x, y. Take a look. Del m, del x. I'll take up del n next. Take a look. Okay. Then this is known as del square z, del y, del x. Happy? And then it is right. Well, okay, good boy. Then similarly, del n, del y, del n, del what I wrote? Del n by del x at constant y. This one. Del n by del x constant y is what? Del n d dx. N is what? Del z by del y at constant x, and this is taking constant y. This is what? Tell me. Del square z, del x, del y. You know that when dz is a perfect differential. Note. When dz is a perfect differential. Do you know this rule? Perfect differential. These two are same. Del square z means order of differentiation. Will not affect. Del square z by del x, del y is del square z by del y, del x. What does it give us? It gives star. Hence write star. Hence write star. Hence, very important. Hence, what you are getting? Tell me. So these two are same. So left hand side same. Hence, del m by del y divided by del y constant x is, tell me, del n by del x constant y. See, is the remove all this. What is this? Is a perfect differential. If dz is a perfect differential, dz is a perfect differential. Now I am applying this rule. So you write here. Right? What is the original? Dz is better. Write this. Dz is m dx plus n dy. Then this gives to this. Okay. Perfect differential. This is perfect differential, right? Perfect differential. I have removed the line, so I applying this rule to these four equations. To what this called? Table 3. Apply quickly. Rule to table 3 equations. One by one. Take a look. dg is VdP minus SDT. Follow. First one. dg. I am writing you. VdP minus SDT. Same. Follow. I am helping you. dz is m dx plus n dy. dg is VdP minus SDT. What is outcome? Del m. Follow. Del m by del y. Back x. Likewise equals to del m by del x. Back y, constant y. Apply. Only criterion is this: dg must be left hand side is a perfect differential. We consider dg is a perfect differential. Is dg a perfect differential? What is a perfect differential? dg. If it is not, why you are writing this? If then you are not entitled to write dg. du is a perfect differential. What I said, all state functions are perfect differential. State functions are, you don't have to. du is a perfect differential. dw is not. dq is not. du is a perfect differential. State function and perfect differential. Perfect is a mathematical term, state function thermodynamic term. Mathematics and thermodynamics is coupled. Is G is a perfect differential? Dz is a state function. I said that is still showing here. So apply. Just apply and make fun. Just apply and make fun. So first one, what is the application? Tell me. Del V by del V by this. Follow it. Del V by del T. The way actually I use this. Del V, not this side. Del V by far I will. Del V by del T under constant pressure is what? Minus del S by del P at constant temperature. One down. dA is minus PdV minus SdT. Apply. Likewise, dA is a perfect differential. Helmholtz has a state function. So del P by del T at constant volume is what, sir? Minus del S by del V. Oh no, minus, sir. Del S by del V at constant temperature. Take a look. Del S. Okay. Happy? 1, 2. Quickly. Next one is dH is TdS plus VdP. What you get out of this? Tell me. dt by dP. dt by del T by del P at constant entropy. Del S by del P at constant entropy is del V by del S constant P. Last. du is TdS minus PdV. Check this. Is what? PdV dP by, tell me, del T by del V constant entropy is minus del P by del S constant. Okay, I'm very sorry that I write fast actually. You should write it. So important. Should write. Okay, very nice hand. So, but these are the things. Okay, remember again, these two are very important. As I tell you, write this. These two frequently used. These two often used. These two often used. Others are what? More of academic interest. Okay. You may be asked to prove this. So that is the interest. If you can manage. But these will be useful practical. Over. Quick. Huh? Okay. Quickly. These are, I think there is no necessity of returning this. Quickly. One. Application. These are known as what? This table. This is known as what? Maxwell relations. Have you read Maxwell relations? Viva question. Have you read? Not that what is Maxwell relation. Have you read? You not have heard of this? The battle. Maxwell, you don't know, sir. Maxwell relations. Applications. Quick applications. Application of Maxwell relations. Of the Maxwell relations. Quick. See, you will be surprised how effective. First one. Take the first one. Del S by del P. I am writing for you. Del S by del P. First one. Okay. Del S by del P at constant temperature minus del B del T at constant pressure. I am trying to find entropy. Effect of pressure on entropy. Last day I have solved this problem. Effect of pressure on entropy. Assignment number 4, 5th problem. If we are interested, what is del S by del P? Del H by del P. Have you read del H by del P any time? Del H by del P under constant temperature. B into 1 minus alpha. Where you have read?
1 minus alpha.
Where you have read? 1 minus?
B into 1 minus.
What is the result? Where you have read? Thermochemistry, second. First, start, second point. Effect of temperature, effect of pressure. Fixed mass fixed composition. So these are about all fixed mass fixed right here. For fixed mass, I wrote here, na? Fixed mass fixed composition and results out of this fixed mass and fixed. I'll stop actually now. Excuse. How much time I have overshot? 15 too? Okay, 1 minute, 2 minutes. Just complete this. Then CP minus CP will be left behind. I will take up actually later. But you do this. What is this? Quick, tell me. Can you recognize this? What you said? Del S by del P. What I said last class? What I said? I gave you. Use this. I am giving you. I'll prove later. Today. Later means today is the later date. What is this? Alpha. Alpha is on with the expansivity. Physically see, physical volume changing with temperature. Expand, what else it is under constant pressure. So alpha is 1 by V is minus alpha V, sir. Here you go. Prove. With the help of the second law of thermodynamics gives this proof. Okay, prove. Why? Alpha is 1 by V del V del T. Recall. What is this? What name of this? Isobaric coefficient of expansion. Expansivity, volume expansion, anything but say that. So isobaric expansivity. So, sir, we got this today. Last day I asked you to take it granted. Take it for granted. Today, no, proved. Right here, proved. To your satisfaction. Who proved this? Who proved this? The second law. Second law gives a great thing. Spontaneity. Weather reaction local. And equilibrium condition. When it stop? When impossible? Apart from that, this type of thing. And next is, last one is. So remove this. Remove this. Tell me. DSDP? Del H del P? Can anyone help me? Del H del P? Last. You tell stop with this. Stop with this. Del H del P cannot. Oh. See here. Please check. DH is TDS plus BDP to. Del H is okay. I'm doing this. Follow. Start. I write that equation. DH is quickly write. Or del H by del P at constant temperature. Do that. Is what? Is T del H by del P at constant temperature. Plus what? V. Right. At least say something. At least one of you. What is del H by del P at constant temperature? Minus alpha V a moment ago. So what it becomes? Minus alpha Vt plus V, which gives you, since time is over, V common. You happy? You are happy? There are still Cp minus Cv proof next day. Next time when we meet, actually, this is small thing. Equal application of this, okay? Easy. Tb alpha square by beta, next class. Proof of Cp minus Cv is next class. Proof of, let me write, proof of Cp minus Cv, Tb alpha square by beta, next class. Next day. Next class. Happy? Okay? So, have you got this? This is proved, right? Again, right? Proved. Today you proved. Previously what you did? Other times what you did? Accepted. Difference. Thank you very much. With these words, we have completed today's class. Okay? You go. Okay? For your next class. Thank you very much. Okay?